Hello, Math Studies students. In this video, we're going to take a look at our 5.2 notes correlation. So let's talk about what a correlation is between two sets of data. A correlation is a relationship between two sets of data where it appears that one set is related to or possibly, but not necessarily, dependent on the other. And a correlation can be represented with a scatter diagram. That's what we will be looking at in this course. So I grabbed an example off of the internet, and this is so tiny. Let me zoom in. I know it's really tiny on your notes. But let's take a look at this set of data that has to do with Old Faithful eruptions. Okay, so we're going to call this, I'm going to put a question mark here because I don't know if this is a dependent relationship or not. I just know that these two events seem to be related. And that is the waiting time between eruptions versus eruption duration. So you'll notice this cluster of points here. So there seems to be a relationship between the eruption doesn't seem to last very long if the waiting time was short, and conversely, if the eruption was really long, you must have waited a long time for it. So I guess if you ever go see Old Faithful, the longer you wait, the better show you're going to see. So again, I don't know if this is a dependent relationship. I just know that there seems to be a relationship between these two sets of data, and we call that relationship a correlation. So let's take a look at some types of correlations. First, we have a positive correlation. So you'll take a look at this scatter plot. You'll notice that the dependent variable increases as the independent variable increases. Okay, so the scatter, if you were to plot the two sets of data against each other, you would see that as the independent variable increases, the dependent variable increases. So here's an example. As the number of hours you spend exercising increases, your fitness level is likely to increase. So you can see kind of that trend here. You can see the relationship between those two sets of data. The second type of correlation is what we call a negative correlation, and that is where the dependent variable decreases as the independent variable increases. So for example, take a look at here. As the number of hours that you train, let's say you're trying to run a marathon, the more hours you train, then the time to complete the race is going to decrease. So you can see that negative correlation. As the independent variable increases, the dependent variable decreases. And then lastly, of course, we could have no correlation. So no correlation just means the points are scattered randomly across the diagram. For example, if we tried to see if there was any relationship between the number of pairs of shoes a person owns and how old they are, you can see how these points are just scattered all over the place. There doesn't seem to be any relationship between the two sets of data. Okay, the next thing we're going to talk about is the strength of a correlation. And this is something, as you think about your IA, something that you might be thinking about. When you compare two sets of data, you might want to know how strongly they are correlated. So we're going to look at three different categories. We're going to look at correlations that are strong. So if you look at this first example, you can see that these points almost lie on a line. There's a very strong positive correlation. Here you see that correlation is a little bit weaker, but it's still, you can definitely see a relationship between the two sets of data. We would say that this is a moderate correlation. And then the last one, we're going to call this a weak correlation. Okay, again, we can still see a relationship. As the one variable is increasing, the other one is tending to increase, but you can see that it's a little bit more loosey-goosey than this example, so we call that a weak correlation. So let's look at this example. Let's describe the following correlations. So this is almost a straight line. So we're going to call that a strong correlation, and because it's decreasing, we're going to say that it's a strong negative correlation. So this one is a strong negative correlation. Okay. The second example, it's definitely a negative correlation again. We can see a relationship, but it's not holding up. It's not looking as much as like a straight line as this one did. So we're going to call that one a moderate negative correlation, and so I think you can see where this is going as we look at the last example. Do you see how we can still see the relationship? There's definitely that downward trend as the independent variable increases. There seems to be a decrease in the dependent variable, but it's a little more scattered, so we'll say that that is a weak negative correlation. In your homework, you will be graphing some correlations. You will be looking for, well, graphing some sets of data and looking for correlations. So you will be doing some graphs by hand, but I want you to be aware that you can also do scatter plots on your graphing calculator. So I have the list of steps here for doing that. We're not going to take time in this lesson to plot any by hand. But you will do that in your homework. But you can also do it on your calculator, and when you get a chance to do that in class next time, here are the steps for that. I want to also point out that correlations can be classified as either linear, which is what we will study in this course, but you could also have, like this one, but you could also have some nonlinear correlations like this example. So that is beyond the scope of this course. It is possible you might come up with some nonlinear correlations and investigate that in your IA, but for this course we will focus on linear correlations. So let's take a look at this example. It says the manager of a recreation park thought that the number of visitors to the park was dependent on the temperature. So to prove his theory, he kept a record of the temperature and the number of visitors over a 2-week period. He plotted these points on a scatter diagram, and in your homework you will be asked to do this a couple times to actually make these graphs. We're not going to take time to do it in this lesson, but once you've made the graph, take a look at it and comment on the type of correlation. So here's his data, and he's saying, okay, I'm wondering if the number of visitors depends on temperature. So temperature would be your independent variable, and number of visitors would be your dependent variable. So as you take a look at the graph, there's definitely a correlation, and it's pretty strong and it's positive. So we can say that there is a strong positive correlation between temperature and we'll say number of park visitors. Okay, how about this next example? It says a mathematical studies student, for some reason, maybe this was his or her IA, wanted to check if there was a correlation between the predicted heights of daisies and their actual heights. Okay, so this student graphed these two sets of data with respect to each other, where the predicted data was the independent variable and the actual height we're calling the dependent variable. So as you take a look at the graph, you can see that there does appear to be a correlation. It's certainly not as strong as the last one, but there does appear to be a correlation, and it's positive, but it's not very strong, so we're going to call that a moderate positive correlation between predicted height, oops, that's an H, height, and actual height. So the next thing we're going to talk about is the line of best fit. So a line of best fit is a line that is drawn on the graph of the two sets of data, okay, so that approximately as many points lie above the line as lie below the line. Okay, so how do we go about drawing a line of best fit? Well, the first thing you're going to do is you're going to find the mean of each set of data and plot this point. So the independent variable will have a mean, the dependent variable will have a mean. That'll give you an ordered pair that you can plot on the scatter diagram. Then you'll draw a line through the mean that splits the other 2 points. And we're going to do this by hand. We're also going to do it on the calculator. So obviously the one we do by hand won't be exact, but it'll be pretty close. One thing to note is that the line of best fit does not need to go through the origin. It often will not, okay? So, for example, let's take a look at the last two examples, the one where we had the number of visitors versus temperature. Okay, so if we were going to draw a line of best fit, we first of all need to find that mean point. So you need to find the mean of each set of data. Now we'll let the calculator do that for us, but the mean number of visitors, mean number of visitors, I'm going to use mu, is 251, and then the mean temperature was 23.3. So we will plot that point as best we can. So we'll start at the origin, we'll go to the right. We'll go to the right, 23.3 units, and then up 251 units, and it's going to be hard to tell on this teeny tiny graph where that would go. I would guess right about here. And then as best as you can, draw, and you will use a straight edge on your homework, but draw a line that appears, I'm not doing a very good job because I pretty much marked out all the points, but on your homework, it won't be so tiny. You'll find that mean point and then use a straight edge to draw the line. This next example is going to be a little bit easier. The mean of the predicted height, or the actual height, was, let's see, 6.09. Again, we'll let the calculator find that for us. And the mean of the predicted height was 6.03. Now, these are measured to the nearest hundredths of, the nearest hundredths of centimeters. So basically, we could call the mean of each one 6 and 9 respectively. So I'm going to plot that point. So from the origin, I'm going to go to the right 6 and up 6, plot that point. See, right 6, up 6, it looks like it'd be right here. And this one is going to be a little bit easier. You'd grab a straight edge and draw that line where it appears that the same number of points are above the line as below. Now, you can also use the calculator to draw a line of best fit. So I've put the steps here, so when you're in class next time, you can try that. Just follow these steps to draw a line of best fit on your calculator. The next thing we're going to talk about is a statistic that I think some of you will want to use in your IA. It's called the Pearson's Product Moment Correlation Coefficient. So what this is a numerical value. So what it does is it allows us to quantify the strength, okay, put a number to that quantifies the strength of a linear correlation between two sets of data. So you can find a value that would actually describe how strongly or how not strongly two sets of data are correlated. The variable that we use for Pearson's product moment correlation coefficient is R, okay? So if you take a look at this chart, I made this chart to show how we interpret the value of R. First of all, I want you to know that R can fall anywhere between and including -1 and +1. So let's make a note of that R can fall between -1 and +1, including. So you'll notice on the chart that if R turned out to be exactly equal to -1, you'd have what's called a perfect negative correlation. If R equals +1, you'd have a perfect positive correlation. And then, of course, if R equals 0, there's absolutely no correlation. And then, if you look at each 25% jump in the direction of either +1 or -1, you can see how these correlations are described from very weak to strong. So what you'll do is you can calculate R, and then once you have that R, you'll find where it lands on this chart, and then you can describe how strong or not strong your data is correlated. So for example, let's look at this one. The data given below for a First Division Football League shows the position of the team and the number of goals scored. Now, what I think they mean by position is the ranking of the team. So find the correlation coefficient R and comment on this value, okay? So if you look at this position, think of it as ranking, okay? So here the rankings are increasing, and as you kind of look, you can see that the number of goals decrease. That kind of makes sense, doesn't it? You can kind of see that negative trend, that obviously the higher the team is ranked, the which would be a low number, the higher number of goals I have. Now, this, for the purposes of this course, we will not calculate any homework or tests or quizzes or on your exam in May. You won't calculate this by hand. We'll let the calculator do that. So I've listed the steps here, so next time in class you can follow these steps. Put the data into your calculator, follow these steps, and when you do, you'll find that R turns out to be negative 0.816, that's to 3 significant figures. Okay, so now let's make a comment about how strongly or not strongly these data are related. So if we go back and look at the chart, negative 8.16 falls here, right? So that means it has a strong negative correlation. So it is very strong. And as we predicted, the lower your position, the lower your position number, the higher the number of goals you have. So we will say, well, our comment will be R is equal to negative 0.816. So therefore, there is a strong negative correlation between, I'm just going to say team position or ranking, and number of goals. Okay, let's take a look at one more example. In this example, the heights and shoe sizes, so the heights and shoe sizes of students at Learn Well Academy are given in the table below. Find the correlation coefficient R and comment on your result. So again, we would use the calculator to find that correlation coefficient, and it turns out to be R is 0.964. That's to 3 significant figures. So if you look above at the chart, you can see that that is very close to positive 1. So therefore, we can say, and this shouldn't surprise anybody, that there is a strong positive correlation between height of these students and shoe size. I would have predicted that the taller the student is, the bigger his or her feet are. So what this statistic allows you to do is to numerically prove what you predicted to be true. So as you think about your IA, you might think about using this statistic. I wanted to include in your notes some formulas. Again, we will not need this for our classwork or tests or quizzes, because we'll always use the graphing calculator to find R, but you may need to show the calculation in your IA. So when the time comes for actually putting this information in the calculator, we won't just say, well, we punched numbers in a calculator and that's how we got R. We would actually calculate it. So these are the formulas that we will use. So just put that on the back burner. This is a formula you may need to use later in your in your IA. So just know that that formula exists and you'll find it in your notes. I also want you to take a moment later and just read about what R squared is, because that's something else you may want to comment on in your IA. We won't need it for our classwork though. Okay, the last thing I want to talk about, and this is really important, and that is causation versus correlation. There are a lot of people that get this mixed up, and there's a lot of misinformation out there in the world because people want to say that these two things are the same, and they definitely are not. Causation is when one event obviously directly causes another event. A good example might be that smoking causes lung cancer. There's a direct causational, if that's a word, relationship there. Whereas correlation is just where one event or one set of data is associated with another. So one good example of that would be people with blue eyes tend to have blonde hair. Those two things just tend to be correlated. They happen together a lot, but that does not mean that the blue eyes cause the blonde hair or the blonde hair causes the blue eyes, okay? So this is really something important to think about, and I want you to listen when you listen to the news and read articles and listen to people talk. A lot of times they will make a situation where they think one thing causes another when they really don't at all. There's just an association. So here's how I want you to remember it. First of all, if you'll remember from geometry, we use an arrow to represent the word oh, nuts, hold on, represent the word, oh, sorry, I'm having technical difficulties here. When you see an arrow, think of the word implies. All right? So, causation implies correlation. Obviously, if one event like smoking causes another event like lung cancer, there's going to be, if there is causation, there's definitely going to be correlation. However, the converse, remember the converse is what we take when we take the hypothesis and conclusion and switch them. The converse is not necessarily true. So correlation does not necessarily imply causation. Let me give you an example. So let's say there would be a strong correlation between grades predicted by a teacher and the grades that were actually achieved by the student. So the teacher might make a list, like at some point I might be asked to predict what I think you're going to get on your papers in May. And there might be a very good correlation between what I predict and what scores you actually achieve. However, that is a correlation. It's not a causation. The predicted grades by the teacher did not cause the achieved grades of the students. So just because I predict a grade, that's not going to cause you to get that grade. So I want you to maybe think about some other types of examples where there are two events where there is a correlation but not causation. It would be really cool if you could come up with an example, maybe that's in the news, a current event where you might hear something reported incorrectly, where two things are correlated, and so the reporter or the writer, whatever, assumes there's a causation when there really isn't one. And that's also another important thing you're going to be thinking about when you write your IAs. You might have two things that are very strongly correlated, but that doesn't necessarily mean that one caused the other. Okay, so this is the homework that you'll be working on in class next time. And if you have any questions over the video, be sure and let me know when I see you.